Okay, I think we can get started. Good morning, everyone. Welcome to the GIS Sea Level Rise seminar. And we're very glad to have Alan Frampton and Sally Brown with us today from the UK. And Alan Frampton is the Strategy, Policy, and Environmental Manager for Southwest Flood and Coastal, which is a shared service between two local authorities in the southwest of England. He leads projects related to geomorphology, environmental change, coastal risk management, and adaptation strategies, and beach and sand dune management. Alan has more than 24 years experience working in the FCERM sector, with 18 of those years in consultancy, where his work included leading the delivery of two shoreline management plans, co-authoring the Coastal Change Adaptation Planning Guidance for England, published in 2015, and contributing to chapters of the CIRIA Beach Management Manual. And Sally Brown is a senior coastal scientist for Southwest Flood and Coastal. Her role is to work in coastal strategy to consider the medium to long-term approaches to how to manage the coast and adapt to sea level rise and other hazards. Prior to working in local government, Sally worked in national government research, knowledge exchange, and academia. She has authored around 60 academic papers, was a lead author in the IPCC special report on the impacts of global warming of 1.5 degrees Celsius, and analyzed sea level rise impacts and adaptation in Europe, Africa, China, deltas, and small islands, all of which provide useful geomorphic examples of coastal change to learn from and apply that knowledge in a local setting. So welcome, Alan and Sally. Very good to have you here.
Thank you. Hi, everyone. Thanks for having us in the introduction, Patrick. Sally, if you can go to the next slide, please. So you're going to have Sally and I share presenting duties. So just to elaborate on the introduction there, our shared service with two local authorities, Bournemouth, Christchurch and Poole Council and East Devon District Council on the central south coast of England. BCP is on the right-hand side of the map box here, and East Devon is on the left-hand side. We've got a diverse range of coast and typologies that we're managing risk in trying to improve the environment in. And we're a team of around 40 staff at the moment, which is quite a big team for a local authority in the UK. Our talk is going to focus on the Bournemouth, Christchurch and Poole area today, which is on the east coast of the county of Dorset. Our authority area is broadly in the zone of the dashed red box on this map. It's a highly urbanised area of a population of just over 400,000 people. It includes low-lying areas in the areas of west and east of the area of Christchurch Harbour and Poole Harbour. Poole Harbour is the second largest natural harbour in the world. You can see it on this left-hand side photo here. Christchurch Harbour, which is the view you can see on the right-hand side image. Sorry, Sally, I should have said move on. I forgot that part of it.
Getting that one now.
Yes. So the second top right image is a view of Christchurch Harbour. Those are both low-lying areas, high risk of flooding with sea level rise, also highly designated for their habitat, migratory birds. Sandbanks at the mouth of Poole Harbour. You can see it marked on the map. It's also the bottom left image, the peninsula there. That's one of the most expensive pieces of real estate in the world. I think it was ranked 4th behind places like Palm Beach and Monte Carlo in 2023. And in between that, along the coast frontage, we've actually got high ground cliffs that are prone to cliff falls due to groundwater instability driven mechanisms that we'll touch on later. So if you go to the next slide, Sally. So the bays we're managing, this is an animation of how the bays formed following the melting of the ice sheets at the end of the last ice age. So We used to have a chalk ridge connecting what is the Isle of Wight on the right-hand side of the animation at this point, and the Isle of Purbeck on the left. And as sea levels rose, it reached that chalk line and breached through and eroded. So that was a rise of around 100 meters or so. And that's formed the two bays that we see now. So you can see Poole and Christchurch bays in a series of offshore banks in the outer part and the Isle of Wight in the foreground. If you can go to the next slide, please, Sally. And the hypothesis is if that process was to continue over a further number of centuries, millennia, the two bays would eventually want to continue eroding back and gradually merge, and you'd form a larger log spiral bay. And if that formed, that black hatched area is the approximate extent we think it would want to reach. You can see, obviously, we've since as humans developed that area, so there's a lot at risk. And a key control point for us in preventing that scenario happening is the area circled in red, which is Hengistbury Head and the Long Groin, and we're going to touch on that a bit more in our talk as well. But that is a key control point for us managing the risk to the whole bay. If you can go to the next slide, please. Sorry. In terms of the current day processes in the sediment transport pathways around the two bays, our dominant wave direction is from the southwest, which sets up a west to east net drift around Poole Bay and into Christchurch bays. And then a lot of the circulation of sand, we believe, a lot of it goes out onto the outer banks in the outer part of the bay system. What's interesting on this diagram is in Christchurch Bay, you have some green arrows showing input from the cliffs in the bay to the nearshore sediment system. We don't have that showing in the Poole Bay side because we as humans have built defences. We've basically stopped that process happening. So our beaches in Poole Bay are no longer being fed by the natural supply from the cliffs that they would have done historically. And we'll come back to that point a bit later in the talk as well. If you go to the next slide, please, Sally. And this is just a picture of how part of the frontage looked in Poole Bay before we started building seawalls and groins, etc., at the base of the cliffs on the left-hand side, and that pretty much the same view present day. So you can see a big seawall is now running along the base of the cliff. We've built groin field, and we've artificially renourished beach, which give us a much wider beach than we would have naturally as well. If you go to the next slide, please, Sally. And again, this is just pictures showing what the beach looked like in, I think it's around the 1960s, early 1970s, before we started renourishing the beach. So you can see very little amenity beach compared to what we have these days. And with sea level rise, there is a chance that this could be our future as well as our past. So that's something to bear in mind. And we'll touch on that as we go forward. And I think it's over to you now, Sally.
Thank you. So one of the things that we wanted to look at today was to think, well, what are we adapting to? We say that we are adapting to sea level rise, but what other things are we having to consider in the process of working towards adaptation, whether it's climate change adaptation or coastal management? So we have to really think about this from a really holistic viewpoint and have to think about many, many different things. When I worked in academia, we often just thought about adapting to sea level rise because that was our one specialist topic. But when you go into practice, you in fact have to look at many different aspects of the same problem in order to get a solution to fit and think exactly what we're adapting to make sure that solution is right for everybody. When we think about some of the challenges that we face on the coast, sea level is definitely one of them. And we often start the journey from that global level. So on the top left here, you can see a picture of the projected global mean sea level rise under different SSP scenarios. Along the y-axis, you've got sea level rise going from 1950, starts at 1950 as a year, so along the x-axis going up to 2150. The y-axis goes up to 2.5 meters, and we're looking over time with quite a range of different sea levels. If we look at some of the lower levels of sea level, we might be expecting 1 meter of sea level rise up to 2150. But if we go to the high end at RCP 8.5, we could be looking to nearer 2. So when we've got very flat landscapes around our local authority, we really have to think, well, what will 2 meters look like in about 125 years' time? And that's a really challenging thought to us. But it's not that simple. We know that sea level rise isn't going to rise in a uniform way around the world, and there's going to be different patterns of sea level rise depending on what's going on with the thermal expansion. We've got different contributions from ice sheets and glaciers as well, and all that mixing as well of the oceanographic properties and the water column as well. And we see different things that are going around the world globally and also locally around the UK as well. We also have to think about land level change. So the image you see there on the right is 3 different places around the UK. So London, Cardiff in Wales, Edinburgh in Scotland, and Belfast in Northern Ireland. So the 4 different nations of the UK. And we've got sea level change there that's going to be projected up to 2100. And again, we've got different scenarios here. We've got the blue showing RCP 2.6, so at that climate change mitigation level. The lighter colour blue, RCP 4.5, and the RCP 8.5 of looking at that higher end sea level rise with much less mitigation going on. Along the y-axis, we've got sea level change. I think this also accounts for land level change as well, going up to 1.2 metres. And we've got time along the x-axis. What we see is around the UK, we get quite a lot of variation in what could be looking at future sea level change. When we're up in Edinburgh, so the furthest north, we actually see less sea level change than down in London and towards the south of the country. And that's because the land in the south of the country is actually sinking as well in response to the last ice age. So we have to take account of this when we're looking at projections around the country. And we also have to consider those sea level scenarios as well. So again, we've got a range. If we look at London, which is probably the nearest place to Bournemouth, we have to look at a range of those sea level scenarios from a mitigation to a non-mitigation. And all of these things we have to build into the design of sea defences and think about the design of the landscape as well over the next 100 years. But taking that study at a national level isn't quite enough. We also have to think about what it means really, really locally. So in one of our studies that we've been doing recently, we've been looking at Poole Bay and looking at the area where we're looking at sand dunes. And again, we've had to look at data from the Met Office to say, well, what could sea level be locally? And we've got an example here of RCP, the diagram on the left, looking at RCP 8.5, where we've got a 1 metre sea level rise by about 2100. And again, this is particular, it's very particular to the area that we're looking at. It's very useful information to us because we can use that to make informed decisions. We may have to think higher. We may have to go to this H++ scenario, so that high end, low probability, where we could be seeing a lot more. But we do have to think about that likely range so that we can make staged decisions. We also like to understand what's gone on in the past as well. So on the right-hand side, you can see some of the work that's been done on our local tide gauge in Poole. This is Holes Bay. It's an area of Poole Harbour, and we've got different places where the gauge has been. And we've actually had to commission work to look at, in this case, annual maximum water levels around the harbour to actually understand how that has changed and what the trend has been like over the last, I think it goes from 1925, or I think it comes up here, to see what long-term changes there's been and also compare those back to the projections to make sure what we're seeing is sensible and making sure we have that sense check when we're looking at design and adaptation. So one of the questions is, what are we actually adapting to? So we're thinking about sea level, but we also have to think about overtopping. We have national planning policy guidance on flooding and coastal change, and that states that we must consider all sources of flooding. It's national guidance, and it means that we have to think about combined sources of flooding, so compound flooding. We know that wave overtopping can occur when the tide is lower than the defence levels. Tidal surge can happen as well. And we're having to look at strategies in this area of what to do about this. And it's really important because we get tidal locking as well. We also have to think about some of the long-term issues with this. The images along the bottom of the screen, we've got a beach area. We've got overtopping onto that seawall. It's along basically a prom. People normally walk along there. We've got, again, another one. It's coming into the prom area, into the seawall. One of the quays near the entrance of the harbour. You can go crabbing here during the summer, but here you can't go there at all. And again, in Christchurch Bay, the other bay, again, we've got overtopping going on. And again, this means we've got to think about public safety and access. We've got to think about what goes on in the sediment as well, because we have to clean it up afterwards. So that's a really important thing, and it has implications for maintenance and safety. Another aspect, I didn't put my image in there. Whoops. Another thing that we're adapting to is about habitat and biodiversity. We have to think about coastal squeeze in front of the defences. We have some of the salt marsh in the around in the area, and we have to think about how this has changed. So you can see two images there. We can see one from 1924 where we've got a lot more salt marsh compared with 1981. We're really concerned about the salt marsh in the area and making sure we've got good quality salt marsh as well, because we also have to think about the other effects of biodiversity and how that really is good for our environment and also for some of the environment designations as well. A really big pressure that we also have to deal with is housing. And one of the things that we have in the UK is a lot of pressure on housing. We've got a growing population, and that population has to live somewhere. And in our local authority, we've got quite a lot of pressure on our coast. In the diagrams that you see here, we're in Poole, so we're right over here on the left-hand side of the sort of far west of our area here. We're expecting in this top diagram, the blue areas you see, this is Holes Bay. We've got the harbour along here, and the dark blue around the fringe here is the flood zones that we expect to see. So we're already putting houses in areas of flood risk. Now, with climate change, we could see these orange areas, they're going to be in areas of flood risk as well. And that's not just from tidal flooding, from sea level rise, we've also got to think about surface water flooding as well. So we have a problem with the existing housing stock. But because we've got a lot of demand for houses, I really think the important thing we also have to think about is how do we fit in the demand for 6,000 new homes by 2033 in the town centre, so this area around here. And this is an area, if I compare it to this diagram, where in orange, it's going to be an area where we're going to expect climate change is going to present a flood risk in the future. We have another area, the Twin Sails area around here, 370 homes here. And again, this is already in a flood risk zone, and it's going to be in a climate change flood risk zone in the future as well. So we're building houses in areas that are going to be in flood risk for the future because we haven't got anywhere else to put those houses. So we've got really intense problems of what do we do with housing? How do we protect that housing from flood risk? At the same time, having these pressures from overtopping, we've got to think about habitat and biodiversity, but we've only got limited land to be able to do that. And we need to protect the town from tidal flooding as well. So again, we're looking at that at the moment of putting a new scheme in place to try and prevent flooding. So that's a really important thing that we've also got to try and adapt to as well. To help with this, at national level in England and Wales, we have shoreline management plans. The aim of a shoreline management plans is to look at sustainable coastal defence around the whole of the two nations. We look at different coastal processes, the different coastal defences, different land use, human and the built environment, and the natural environment as well. The Shoreline Management Plan sets up the policy for the next 100 years, and we look at it in 3 epochs. So 0 to 20 years, 20 to 50 years, and 50 to 100 years' time. Now, these plans they came out from around 2007 to 2011. So we're at the end of Epoch 1 now. So we're thinking about what have we done? What do we have to do? Now, the Shoreline Management Plan is divided into 22 different areas, which you can see on the right-hand side. And we are right at the bottom at the south coast here in the middle. So we have our expectations what to do in our area, and we have similar expectations linked up around the country. So we're trying to join up with different intent. And we have 4 different policies. One of them is called no active intervention, where we don't do very much to the coast, which mostly happens along natural shorelines. We have managed realignment, where we may have barriers or seawalls along the coast at the moment, maybe embankments, and they may be removed with time to create habitat, or they may have to come back on safety grounds, or if there isn't enough funding to keep them where they are. We also have hold the line, which again, along populated coast of Bournemouth, we would like to hold the line because we've got a lot of assets behind there and a lot of infrastructure. And then we have advance the line, which we don't do very often, mostly because it's not needed, but sometimes we do with space. If you're doing land reclamation, we've got areas around the country, such as in Blackpool, up in the northeast here, where they've advanced the line and put the defence slightly seaward because they haven't got space to put it anywhere else. But mostly we're looking at areas that are going to be realigned or hold the line. No active intervention doesn't tend to happen so much in populated areas. And this sets the intent of what we're going to do and brings that shared vision that we've got around the country and in our local area from the lots of different stakeholders who have an interest in the coast. So what does this mean locally to us? This is Poole and Christchurch Bays, where we've got the shoreline management policy. Here we've got the blue lines, which indicate the hold the line. We've got the pink lines, which indicate manage realignment. We've got green for no active intervention and orange for hold the line or advance the line. Around the shoreline, you can see 3 different lines in front of the coast, and each of these represents a different epoch of the policy. So the one nearest the coastline are the expectations set out in about 2010 for what was going to go on in about 2025. The middle line is the 2055 intent, and the outer line is the 2105 intent. What we can see here around our coast, I'm going to be starting with this box here around Christchurch Harbour. We've got some works here where we've got pink lines, and they indicate where we've got managed realignment. We've got a scheduled ancient monument at the top of the headland here, but this is a largely rural area. We go around the bay where we've got a lot of population around Bournemouth, and this is hold the line. So we've got to keep that shoreline where it is, and it's a cliffed area, but we're looking at the shoreline around the beach and the seawall. As we go around to Poole Harbour, we also see a lot of hold the line, lots of population in this area, so we want to keep the shoreline where it is. And as we go around to the south of the harbour, we've got some intent to do some realignment. And at the south of the harbour, where it's a largely rural area, it's green, which means we've got no active intervention. And the same goes around the edge of the bay, where we've got some nice rural areas as well. And then we've got some smaller towns around here where we've got a mix of policies. So this intent is really important to show. It gives everybody a common vision. It's available to the public, so they know what's happening. And it's really important that we communicate that very, very clearly. That's not the only thing that we need to take account of, though. We have this big spider diagram. There's lots of other things that we have to take account on. We have shoreline management plans in this box with other flood risk strategies. But around all of that, we also need to think about things about planning. We need to think about climate change projections, climate change risk assessments, marine planning policy statements, EU Water Framework Directive, Floods Directive, Habitats Directive. So all of these different plans have to feed into the shoreline management plan. So we have an awful lot to adapt to there. It's not just about the management and sea level rise. There's a lot more that we've got to think about. So this produces a lot of challenges in the way that we manage our coast and the approaches that we need to deliver a really good shoreline strategy. In order to do that, we also have to manage our coast as well. And we have a network in the UK of looking at some of the ways to monitor the coast, sometimes through collecting beach profiles. We've got a lot of these all around the country, all around England, in this case example here. We've also got wave data, aerial photography and habitat mapping that helps inform those policy decisions. Because without good data, we don't know how to make a good decision. So it's really important that we collect data and analyse it thoroughly and properly to make good decisions. We do this locally as well in-house. So we've got drones, we do a lot of GPS surveys and also bathymetry surveys as well. So going along sandbanks, which is what Alan said is one of the pristine real estates, into the harbour. We do a lot of monitoring around there and other parts of our coast to make sure we know what's going on and that the coast is behaving itself. So that's our thoughts to date. I'm going to pass back to Alan now, who's going to be thinking about how we're going to be adapting to sea level rise using some of the examples from the groins we've got and the long groin, which is at the end of one of our bays. So over to you, Alan.
Yeah, thanks. So yeah, I'm going to talk about a couple of our schemes that we're currently in process and how we're managing this. So if you can go to the next slide, please, Sally. So I'm going to start off talking about our open coast in Poole Bay. So this is a bit of a timeline of the history of how humans have interfered with the natural system since the late 19th century. We started building sea walls to stop coastal erosion, wave action at the base of the cliffs. That was successful in that it stopped the sediment supply from the cliffs feeding the beaches. But to counter that, we started building groins to try and retain what limited sediment was entering the system. That got us to a point into the middle of the 20th century, but we were still having cliff failures because our cliff failures, although no longer driven by wave action at the toe, because we'd stopped that with the sea walls and groins. Our cliff failures are actually driven by groundwater and rainfall as well. So they started introducing various cliff stabilization systems, big drainage systems, regrading cliffs, nailing them, etc. But that didn't then address the fact that we had no beach because we'd stopped the natural sediment supply. So since the 1970s, and it's one of the longest running artificial beach nourishment schemes in the UK, we have placed of the order of 6 million cubic meters of sediment from offshore sources along the Poole Bay, Bournemouth frontage over the last 50 or so years. And that's the beach we currently see. So our frontage is largely completely artificial at the moment and retained with renourishment about every 5-6 years. If you can go to the next slide, please, Sally. So the current scheme program of works that we're doing that under is called the Poole Bay Beach Management Scheme. That is a scheme that is aligned with the Shoreline Management Plan policy to hold the line. We've since done a strategy that said the best way to do that was continuing our program of groin replacements and periodic beach renourishment. And then our current business case is a £36 million program of works to protect 5,810 properties. It's a program that has in it replacement of 26 of the timber groins around the bay. We're currently in our final 2 years of that program, undertaking 2 beach nourishments and repair and upgrade of the Hengistbury Head long groin, which was first built in 1937. We've got a slide on each of those now, so if you can go to the next one, please. So in terms of our timber groin renewal, we do these over in 2-yearly contracts, working in various zones. We tend to do between 3 to 5 groins most programs. We recycle a lot of the timber buried in the beach. So the bottom left diagram gives you a sense of the scale of these structures. So we are going down to the underlying clay layers beneath the beach to form a seal. And then we install new tropical hardwood in the top 5 or 6 planks of these. And then some of the timber has been reused for other things. It's cladded a local building along the Bournemouth seafront. It's also been used for a footbridge as part of a flood defence scheme in Cornwall in the wider southwest region, which is the image in the middle here. If you go to the next slide, please, Sally. Beach nourishment is targeted based on our monitoring data. Our last campaign was in the January to March 2021. We took 350,000 cubic meters of sand from a location in the southern North Sea, which is about a 30-hour shipping cycle away from our site to go and fetch that and bring that to shore. And it's pumped ashore through a large pipeline that is moved along to the depleted areas, which are highlighted in blue on this map. You can go to the next slide, please. And then the Hengistbury Head long groin, as I mentioned earlier, is a key control point for us. So the structure on the left was built in 1937. You can see it was looking well past its prime. There were gaps in it. It was starting to collapse. It was a safety risk as well. So that was rebuilt last summer. The picture on the right is a photo of it near completion. It's been widened and raised in height, so it's got a design life of 100 years. And it will stabilize that key control point for us for that duration. And as part of that, we actually installed a range of ecological enhancements in the intertidal and subtidal, various rock reefs and subtidal units to create additional habitat space for species there. If you can go to the next slide, please, Sally. So the other scheme I'm going to talk about is one that's currently in progress. It's called Poole Bridge to Hunger Hill. This is around that area of Poole town that Sally was showing where the housing pressure was. So if you can go to the next slide, please. So Sally talked about the housing pressure, the existing housing stock, and the desire to build more housing. This is addressing some of the risk that was flagged with sea level rise. So the scheme is effectively going to protect in the order of 4,000 properties over the next 100 years design life with it. And the principle is that we are going to raise the existing defence level by putting a new piled wall in front of it. And you can see the sort of conceptual illustration of that impact on the 2 right-hand diagrams. So you've got the existing quay wall, the piling going in, and we will have a big high wall there for a period of time. The idea is that then regeneration and redevelopment behind that can come in and raise the land levels up, so you reduce that visual impact of having such a high wall. That will buy us a period of time. The question for us is how much time will that buy us before we have to raise the walls even higher? And then you start getting into the discussion around how high should we be building, given the risk we're storing up in the area and what we know about climate change and the sea level rise. If you go to the next slide, please, Sally. Hopefully it's moving.
Has it not moved?
No.
Try again. Has it moved?
Yeah, there you go. Yes, thank
Yeah.
you. So this is a long-standing problem. This is a photo from 2008 when we had high tides. This happens quite frequently. You can see the extent of flooding there already. This is only going to get worse if we don't do anything to raise the defences. You can see the development, how close it is behind the quay wall there. We've got the Royal National Lifeboat Institute, its National College site here as well, which is where those lifeboats are parked there. And then the garages and things there, that's the hinterland behind, and you saw on the map earlier the extent of the flooding it can get to, so that can reach quite a way inland. If you can go to the next slide, please, Sally. So this area has got 3 owners: the harbour commissioners, the Environment Agency, and ourselves as local authority are responsible for different sections. Harbour commissioners and the Environment Agency raised their sections in previous years, so you can see we've suddenly got a disparity in defence levels between 2 of those areas. You can see which is the local authority, it's our patch, which hasn't yet been raised. If you can go to the next slide, please, Sally. And the scale of the raising we're talking about here is illustrated on here. So just by 2050, so in the next 25 years, we need to come up to by about 0.6 meters to give us with a freeboard for wave disturbance as well. And over 100 years, we're talking more like 3.2 meters. So quite a significant rise, as Sally illustrated with the climate change projections. You can go to the next slide, please. And we've got a range of asset conditions as well. We've got some assets that are in a pretty good condition and gradually coming down to condition 5, where they're pretty much in a very poor, almost failed state as well. So we've got a range of existing conditions that we're trying to deal. So putting in a consistent new asset is going to be beneficial from that point of view as well, because it will give us guarantee. If you can go to the next slide, please. And so the scheme we're doing at the moment, it's in several zones tackling the problem. We'll gradually be raising the wall up. This is an adaptive design, so our whole scheme is designed for 100 years, but we're only going to design or build to height for to about 2070 initially. The design is adaptable, so you can add additional height at a later date, but it reduces the immediate visual impact that you're talking about. And it gives you a sense here, the scale that we're talking about again. So the table on the bottom right shows the heights we need to get to over the 100-year period as well. So and we have to include a 300 mil freeboard allowance on top of any climate change sea level rise projection as well. I think that's me. Over to you, Sally.
Okay, thank you. So we also, as Alan was alluding to there, we have to think about the long term. A lot of our schemes, they could be designed to last 50, 30, 50, 60, 70 years. But we have to think about that in a staged way, not just for the visual amenity side, but also for the cost side as well. And thinking about how the land behind it is going to change, how we're going to cope with the different pressures like housing and things as well. So we have to start thinking about adaptation pathways. Now, when I worked as a postdoc about 10 years ago, we were doing a lot on adaptation pathways from more of the theoretical side. So it's been lovely to actually see how these come into practice, because they're actually really challenging to do, because we have to think about how we're going to adapt, what we're adapting to, and where those thresholds are, where you have to think, well, actually, I'm going to do this for so long, and then it will only last to this level of sea level rise, and then I have to change to a different path. So how are we going to do that in practice? So it's all about thinking proactively, and we're having to think about that future of change through a number of different pathways, and making sure that our actions, right from where we're thinking from the shoreline management plans to right to when we undertake schemes, are actually coming in a staged way, think about uncertainty, we're thinking about long-term response to the morphology, and also thinking about how the various assets on the coast are going to respond. Are they going to be robust? Are they sustainable to cope with different levels of sea level rise, overtopping, habitat change, and population change? So we've got a lot of things to think about. And a lot of this, we have to follow the government rules, either through sort of the economics of it, thinking about Treasury guidance, and some of the grant and aid rules as well, and also from central government, which is DEFRA, which is the Department for the Environment, Food and Rural Affairs. And again, this makes it sure that we're consistent in our approach with others around the country, but also making sure that we're thinking about some of the unique challenges that we face on our coast here as well. You mentioned monitoring earlier on in the talk, and this is really, really very, very important because it provides us with triggers. So we understand what's changing and why. And without those triggers, we can't actually indicate when are we going to have to change different management actions. So the graph here that you see on the right-hand side, up the y-axis, we tend to have an indicator value such as sea level rise, and along the x, we've got an indicator such as time. We've also got different changes there. So each of the lines that you see have a rate of sea level rise. And we have to think about when those triggers are first of all going to be reached. When we're thinking about that, we have to think about the different thresholds and when a decision point is needed. So a threshold is a limit beyond where there could be a fundamental change, and we need to change our approach. And a decision point occurs at a time before the adaptation action is needed, indicated by a trigger and an approaching threshold. So we have different stages of getting up to when we've actually got to do something. And these are different really key components and putting together the adaptation pathways. The diagram shows that if we head along initially the blue line, we're recording, say, in this example, sea level. But then we have different moments in time that we have to take account of decisions. So we think about how sea level could change, the different bands of uncertainty that we talked about earlier, and thinking about how it could change, and the lead-in time that it takes for planning and construction. And that's really very, very important because in complex environments, that lead-in time can be very significant. So we're working on our local strategy now. That strategy started in 2014. We're reviewing it at the end when it sort of comes to the end around 2030. And so it's taken us about 15 years from some of those ideas being put down and agreed to actually actions taking place. So it's a very long timescale that we're having to think in advance to make sure that we're keeping our options open, but not closing them or doing things too early that becomes ineffective or not cost effective as well. Within the strategy itself, we have our different approaches, and you can see a kind of adaptation pathway starting here. And this is still in the early stages to think what we're going to be doing. We are reviewing this at the moment. We have, thinking along here, we've got our management approach. We've got thinking about maintenance of seawalls. We've got replacing seawalls. We've got raising seawalls options, more raising. And we think about these depending on the sea level scenario, where it's a low scenario in green, a medium scenario in orange, in red, the upper end, or the pink at the upper end with a surge. And we think about how these different options or the different adaptations could occur with different levels of sea level rise per asset or per scheme. And it's really important that we integrate those into that design to make sure we're working effectively. So one of the questions is that you can adapt, but will it solve all of our problems? What ongoing challenges do we have? Because even if we do adapt, we can only do so much and there's always something left over. So one of our ongoing challenges is beach management. In 2022, it was a very, very hot year here in the UK. And the beach at Bournemouth, particularly post-COVID, was absolutely jam-packed, as you can see at the top right. It was still jam-packed in the top 7 in the 1970s as well in the bottom right. So we have a lot of tourism in this area, and the economy just really feeds off that tourism. So beach management is really, really important. If we get beach lowering, it means we can't get so many people on the beach. We've also got things about storms that we need to think about, overtopping, and that could mean damage to infrastructure as well. So just because the beach is there, it still has to be looked after, and we have to keep replenishing it, because if not, we're going to have failure of that seawall, assets could fail, and that's going to have implications for the infrastructure and the cliffs behind. To go forward, we could do nothing. we could return the coast to its natural state, but realistically, it's not going to happen because we've got so much infrastructure behind there. We could look at different options to try and retain a beach in the long term by looking at coarser sediment grading, but the tourists like the nice soft sediment. So again, that's a challenge for us. We could look at different seabed and nourishment methods if we want to think about different cost-effective methods. Or we could look at different coastal protection approaches, looking at larger walls or rock revetments as well, or sand dune creation to look at the natural environment. So we've got lots of different options that we can think about. Just even if we know what we want to do, we have to think about how we're going to do it. These problems aren't unique to our area, and there's many locations where it's going to be more challenging to keep beaches where they are today, particularly as sea levels rise and we can't roll back because there's hard defences behind. A second challenge we have is sediment availability. For context, Poole Bay is just off the left-hand side of this diagram here. One of our key problems is trying to get the right type of sediment for our beaches of the right grade, quality and volume, and for an appropriate cost as well. We've traditionally used some of the sandbanks off the coast of the Isle of Wight, which is not too far from Poole Bay, and that's kept our costs low. But for the first time in 2021, we had to go to the south of the North Sea. It meant that we had increased construction costs, the carbon footprint is higher, and there was also increased risks of delays with the weather. So in the long term, we're thinking about where can we get sediment from that's sustainable, but also making sure that it's cost effective as well. So sediment availability is also a problem for us. Another one of our challenge is also funding as well. In the UK, the funding is quite complex. We can get grant in aid from central government for some of the works, but we also may have to ask for partnership funding from other funding pots to help protect homes from flooding. It may mean that we approach businesses. So in the UK, there's caravan sites around the country, for example, who actually privately defend their own coast because they can't get grant and aid from the government. We are looking about how best to do this, and at the moment, a new system should be coming out next year about how the government intends to fund this in the future. But it does leave shortfalls in funding about how we address issues like cliff instability, which doesn't count under those rules. It doesn't consider coastal landfills, wider adaptation options such as relocation, which some councils will have to consider, and also resilience measures for flooding for householders, and thinking about place-based resilience as well. So funding will only go so far, and it will only go for certain things as well. Another problem we have is cliff instability. We have cliffs backing the whole of our bay. The cliffs do fail because they are driven by rainfall as well. And you could see a cliff failure here in 2016. It's gone over the cliff lift right onto the prom. I don't know if this is a toilet or an ice cream kiosk. It could be both that's going on there. It's a safety aspect. We've got commercial aspects of risk there as well. We've got the road at the top of the cliff. So we have a lot of issues about how do we manage failing cliffs, and it's not unique to our area. There's no national funding to doing this. So it's a really, really big challenge. And with climate change, we could be seeing more of these types of falls and landslides. We've got drying cliffs and then sudden rainfalls as well. So we have challenges of how to manage them and to get the funding to do it. And one of our big issues is we've got a lot of infrastructure on the top of those cliffs. So we have to think about how we manage that as well. Our fifth challenge is about relocation. We'd like to stress we're not considering this as a council, but again, we have to look at national guidance to think about how we can do this from the planning response, and to think about the different options available, whether we do nothing, we protect, we accommodate, advance, retreat, or we look at ecosystems based. This is really challenging for us. We have a lot of pressure on housing. We build housing by the coast. We think about regeneration sites as well. We don't really want to move on to the green belt to build houses. So we're trying to think about how we can best manage the coast in the best possible way. But again, there's no funding for this. So it's another big challenge that we're seeing from government. So to summarise, managing coastal risk and adapting to sea level rise and other hazards is really, really challenging in practice because there's so many different things that we have to think about. We've got significant investment in this area over the next 100 years in thinking how we're going to manage the coast and the various strategies and schemes that we're coming up with. It is largely artificial, our coast, and it protects a really highly urbanised area, but there's significant benefits of having the beach, not just for coastal protection, but for the local economy as well. We like to take an evidence approach to decision making and monitor our coast so we can make wise decisions. And we have to think about climate change in everything that we do to make sure we're looking about that long-term strategy, thinking about not just thinking of protecting a coastal line, but the whole resort for the people who live and work here and for the people who holiday in this area. Finally, there are many challenges for our coastal communities, not just in the Bournemouth Poole area, but we also have to think about some of these challenges. They're global challenges as well. They're challenges that we see in the UK. So we need a lot more joined up approaches and sharing so that we see what possible futures that our coast could have. And sea level is just one of those problems that we need to face. But when we think about what we need to adapt to, there are many, many problems. And we sort of love to learn from academia to understand what could we do and what can make our coast a really nice and sustainable place to live over the course of our lifetime and far beyond that. Thank you very much. We do have some links there if you are interested in finding out a bit more, and we're both very happy to answer some questions as well. Thank you.
Okay, thanks so much, Sally and Helen. Do we have any questions? So I was wondering about the extent to which you use climate model projections, and like if there's any improvements to the way climate models do the projections, or more information that they could provide that could help you in your work.
Did you want to answer that one, Alan?
Yeah, well, I'll start. See
Yeah.
if you've got anything
Okay.
to add. Yeah, I mean, the framework we work in, so the international projections get translated to the UK guidance, and then that gets translated by DEFRA and the Environment Agency to guidance that we have to apply to our projects. So that translates typically to a core scenario projection, and then we have to test the sensitivity to the higher scenarios. So we're beholden to that process, really. Everyone's meant to follow the same guidance. So I guess the frequency of the updates is actually the unknown, and all I can see is that we're probably expecting more sea level rise than we're currently planning for, which is probably not helpful. So are we planning long enough with the right sea level is, I guess, the question, but we have to do some plan somewhere.
Yeah. So a lot of what we have again with national guidance is that we have our national flood risk assessment and our erosion as well. So we have to take those into account at a national level. But beyond that, when I was working in national government, one of the things that we're saying, well, what about non-stationarity? Where are we seeing changing extremes that aren't being worked into that guidance at the moment? Because there's only a limit of how far you can take that at a national scale. So for us, when we're looking at projections, it's not just about thinking about the mean, it's also thinking about some of those extremes as well. So from a national side, there's a lot more interest in that coming in, because again, we have to adapt to the extremes, not just adapting to the mean line as well. But we have to follow the national guidance on that when we're doing schemes.
Okay. Looks like we have a question from Brian.
So for what you're doing, how big a concern is inland rainfall happening at the same time as you have a storm?
It's quite in terms of sort of a statistical joint probability, it's quite low, but it can happen. And I guess our bigger concern longer term is that as sea levels rise and we're raising our tidal defences for that, then we're actually blocking off the drainage. So we're probably going to have to look at more pumping solutions, which come with their own challenges as well. So it's a tricky balance. Some of the strategy work that's happened in the past is not adequately joined up with that aspect, and it's something Sally mentioned. We're about to start reviewing the Poole Bay Harbour strategy, and it's one of the key questions we want to look at in there is what is that scale of that risk now, and how will that change in future. A parallel piece of work we're currently doing is it's part of our local plan, which sets out our planning policy for the area, including housing, etc. We have to do a strategic flood risk assessment. So we're actually doing that piece of modelling work for Poole Harbour at the moment, looking at the combination of surface water and tidal flooding.
And looks like Thomas has a question.
Hey, thanks for the talk, you two. I really like the breadth of the content you covered today. My question is, in this work, I imagine you encounter a bunch of different stakeholders who are interested in these plans that you're developing. What kind of stakeholders have like are bringing the most difficult challenges to the table in terms of incorporating and addressing their concerns in the context of what's feasible or what's fundable?
It's really diverse depending on which bit of coast we're working with. Our communities are completely diverse. We've got some of the most coastal communities in the UK. Some of them are the most deprived parts of the country. And then in other parts, as I mentioned, places like Sandbanks, they're really wealthy, they're really affluent, knowledgeable. We've got quite a number of retired people down here who are experts in their field, who've got quite can bring that challenge. We always engagement is key to everything we do, so we always try to reach out across the whole community and try to get a diverse range of views whenever we're doing this work, and bring people on the journey with us, capturing the local knowledge, information, bringing them involved, showing them the work as we go along for how we're assessing the science, what we interpret it to be, how that translates into an options appraisal of what is feasible as well as what's desirable. And we take a multi-criteria assessment approach to options appraisal, where we try to balance and factor in all the competing interests, both from the community, individual householders, businesses. We also have to represent the natural environment designations, some of which have legal drivers behind them as well, and historic environment, and all those factors. Yeah, we're always kind of balancing multiple spokes on the wheel.
Not easy to do, I imagine. Keep up the good work.
Thank you. Yeah.
Okay, any other questions? Well, if not, I guess we can stop there. So thanks again so much, Alan and Sally.
Thank you for having us.